projects. In this video, we are going to explain about the project, which is lane and pothole detection using Yolo. Coming to the introduction of the project, lanes are demarcated pathways on the roads to guide vehicular traffic. Detecting lanes is crucial for autonomous driving systems and advanced driver assistance systems. Potholes are the depressions or the holes in the road surface caused by wear and tear, weather conditions, or the poor construction. They pose hazards to vehicles, causing damage and accidents. The project aims to develop a system that is capable of real time detection and localization of lanes and potholes on road using YOLO. Traditional methods for lane detection often rely on handcrafted features such as color based segmentation or edge detection algorithms. These methods struggle with varying lighting conditions, road markings, and complex environments. Pothole detection traditionally involves manual inspection or specialized equipment, making it labor intensive, time consuming, and not suitable for real time monitoring. The proposed system integrates OpenCV for lane detection and YOLO for pothole detection, leveraging the strengths of both approaches. OpenCV technique can be used to pre-process images, extract lane markings, and estimate lane parameters. YOLO is employed to detect and localize potholes, offering robustness and efficiency for this task. By combining these methods, the system aims to overcome the limitations of the individual approaches and provide accurate detection of lanes and potholes in real time. Coming to the objective of the project, the main aim of the project is to develop a system that is capable of real time detection and localization of lanes and potholes on roads to enhance road safety and facilitate autonomous driving systems and advanced driver assistance systems. The project aims to primarily utilize YOLO, which is You Only Look Once, deep learning algorithm for object detection. Specific versions such as YOLO V5, YOLO V6, and YOLO V7 are employed based on the project requirements. Performance evaluation is conducted using standard evaluation metrics such as mean average precision, recall, and precision. By comparing these metrics across different algorithms or the variations within the same algorithm, the project aims to identify the most effective approach for lane and pothole detection. The aim is to enhance road safety and transportation efficiency by developing a system for early hazard detection, benefiting drivers with smoother driving experiences and enabling proactive maintenance for authorities. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. So coming to the first step, which is importing the packages. In this step, necessary Python libraries and packages are imported. We imported TensorFlow for deep learning, OpenCV for image processing, Flask for web application development, and SQLite for database management. The next step is importing the dataset. This step involves importing the dataset that contains videos of roads with lanes and potholes. Coming to building the model. In this step, deep learning model YOLO is initiated for pothole detection. Training the model. The model is trained on the dataset. During training, the model learns to map input features to target outputs by adjusting its parameters based on the training data. Coming to the next step, which is Flask framework with SQLite for sign up and sign in. Flask framework for Python is used to create a web application. SQLite, a lightweight relational database management system, is integrated with Flask to handle user authentication functionalities such as sign up and sign in. The next step is user gives input as videos. User provide input in the form of videos containing road scenes. These videos are captured using onboard vehicle cameras and uploaded from local storage. Coming to the next step, which is train model is used for prediction. The input videos are passed through the train model for prediction. The model identifies and localizes lanes and potholes in each frame of the video, generating predictions based on learned patterns and features. The last step is final outcome is displayed through frontend. The detected lanes and the potholes along with any relevant information are displayed to the user through the frontend of the web application. This include visualizations overlaid on the input video frames on the textual descriptions of the detected objects. Users can interact with the interface to view the results and make informed decisions based on the detected road hazards. Algorithms which are used in the project are Yolo V5. Yolo V5 is also known as You Only Look Once version 5. It is a cutting edge deep learning model specializing in real time object detection. It excels at both speed and accuracy, making it ideal for tasks like self driving cars and video surveillance. Yolo V5 prioritizes user friendliness and offers diverse pre trained models for various needs, while also allowing for customization for unique objects. Overall, it's a powerful and versatile tool for object detection in numerous real world applications. The next algorithm is Yolo V6. It is also known as MT Yolo V6. It is a next generation object detection model building upon the success of Yolo V5. Designed with industrial applications in the mind, it offers an exceptional balance between speed and accuracy. It features innovative architecture improvements like efficient rep backbone and rep pan neck, leading to better performance than its predecessors. Yolo V6 provides various models catering to diverse needs, making it a valuable tool for real time object detection in industrial settings. The last algorithm is Yolo V7, standing for Yolo Look Once version 5, region supreme as the fastest and most accurate real-time object detection model yet. It surpasses all the previous iterations of the Yolo, achieving both top speed and top accuracy within this category. Notably, it even outperforms complex models like Cascade Mask RCNN in both speed and accuracy. This groundbreaking model is open source and readily available for various applications. We have used mean average precision, which is MAP, and precision and recall, which are the performance metrics to evaluate all the models built in the project. So here we have performance comparison graphs for all the detection models built in the project. This is the MAP comparison graph, where x-axis represents mean average precision score and y-axis represents algorithm names. Similarly, we will have for other two graphs also. Coming to mean average precision, which is MAP, it is a metric commonly used in object detection tasks. It calculates the average precision for each class and then takes the mean across all the classes. Average precision, in turn, is the area under the precision recall curve. This is precision score comparison graph. It is a metric that measures the accuracy of positive predictions made by a model. It is calculated as a ratio of true positive predictions to the sum of true positives and false positives. This is recall comparison graph. Recall is also known as sensitivity or true positive rate. It measures the model's ability to capture all relevant instances of a class. It is calculated as a ratio of true positive predictions to the sum of true positives and false negatives. The algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we have to open the code folder which contains source code files. This is the code folder of the project. This is the dataset folder in which we have the data. We use the data for training the algorithms. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. This is the models folder in which we have algorithm information, and that will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is signup.db file. This file is a database file used to store the user information. Now, to execute the project, we have to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we have to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. By this, current directory will change to the code folder's path. So here we can see that current directory is changed to the code folder's path. And here we need to type the command python space app.py to compile app.py file and then click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. This is the localhost and this is the port. Now we have to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built by using the Flask framework. So first, to execute the project, we need to sign up. So click on sign up link. Here we need to enter all the registration details if we are registering newly. I have already registered and I have an account in it, so I'll directly sign in. So click on sign in. And here we have to provide our credentials, which are the username and the password. So I'm giving my username and the password. And now click on submit. We have logged in successfully and we are redirected to prediction page. As we have already mentioned that we are going to do lane detection as well as pothole detection. First, we'll do lane detection. For that, click on lane detection button. Here we can see a choose file button. We need to click on that for uploading the road related videos. So click on choose file. From the test cases folder, I'm choosing this file to upload. Now click on open. Here we can see that video has been loaded. Now we need to click on upload. So here in the video, we can observe that lanes are being detected by the green color. Here you can observe. Now we will try uploading the other video. Click on back arrow. Click on choose file. This time we will upload this video. Click on open and then click on upload. For this video, also we can see that lanes has been detected by the green color. This lane detection helps in autonomous driving, traffic monitoring, road maintenance, and accident investigation. As we have completed lane detection, now we will do the pothole detection. So click on back arrow. Click on pothole detection. Similar to lane detection, we have choose file button here to upload the road videos. So click on choose file button. I'm uploading pothole 2 video. Click on open. And now click on upload. So here in the video, we can observe that potholes are being detected with the red color bounding box and with the label pothole with the probability score. You can observe here, wherever there are potholes, it is being detected. Pothole enables timely identification and repair of the road surface defects, enhancing road safety, minimizing vehicle damage, and optimizing maintenance efforts for transportation infrastructure. Now we will try giving the other video. Click on try again. Click on choose file. This time we will upload pothole 1 video and now click on open and then click on upload. So here in the video, we can observe that potholes are being detected with the red color bounding box and with the labels and with the probability score. Now click on logout. In this way, just by uploading the video to the system, lanes will be detected as well as potholes will be detected. Conclusion of the project. The developed system successfully detect lanes and potholes in real time, contributing to enhanced road safety by providing early warnings to drivers and facilitating proactive maintenance by authorities. Leveraging state-of-the-art deep learning algorithms such as Yolo V5 for pothole detection and OpenCV for lane detection, the system achieves accurate and efficient object detection in diverse road environments. The integration of the Flask web framework and SQLite database allows for seamless user interaction through a user-friendly frontend, enabling users to access and visualize detection results conveniently. The modular design and flexibility of the system makes it scalable and adaptable to varying requirements and conditions, paving the way for potential future enhancements and extensions to address emerging challenges in road safety and transportation.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, Please visit True Project's YouTube channel and subscribe.